Hello everyone, this is the demonstration video for SIT202 Network and Communication IPv4 addressing scheme. So let's start the presentation. So, firstly, we will talk about IP address. What is an IP address? So IP address is a numerical value, numerical label assigned to each device connected in a computer network, and it uses internet protocol for communication. It's of two main functions. First one, to identify the host or network interface. Second, then providing the location of device in the network. Then it comes to the IPv4 addressing scheme. So the IPv4 is the fourth version of internet protocol. It uses a 32-bit number represented in 4 octets, and each octet is specified by a period and can range up to 0 to 255, ranging from 2 raised to power 32 addresses, that is over 4 billion addresses. IPv4 addresses are typically represented in dotted decimal notation like 192.168.1.1. Then it comes to the type of IPv4 addressing, IPv4 addresses. So there are mainly three type of addresses. First one is unicast. It is a unique node, and this IP address is for a unique node on a network. Then it comes to a multicast. Multicast identifies a group of devices interested in receiving the same data simultaneously. Then it there is a broadcast. So broadcast is an IP address that allows communication to all the devices on a specific network or a segment. Then we have the classful addressing. So it is an addressing where the IPv4 addresses are divided into 5 classes: class A, class B, class C, class G, class E. And these classes are determined by the size of network portion and the host portion of the address. However, this system led an inefficient address allocation and was replaced by CIDR. So let's talk about the classes in the class full addressing scheme. So the class A, it is intended for large networks, and it is intended for large networks with a million of hosts ranging 0.0.0 to 127. And class B, it addresses are suitable for medium sized network with a range of 128 to 191. Then there is class C. Class C addresses are used for small networks with a few hundred hosts. Its range is 192 to 223.255.255. Then there is class C. It is for multicast. It is reserved for multicast groups, and its range is 224 to 239. And then there is the last one, class C. It is an experimental class, and it is reserved for experimental use and not commonly used. Its range is from 240 to 255. Then it comes to CIDR. So CIDR is basically a method of allocating IP addresses uh, with the IP routing. So it is more efficient allocation of IP addresses because it introduced the concept of subnets and enabled the better utilization of address and space, improving routing efficiency. Then we have subnet. So subnet is a logical division of IP address, and it allows a single network to be divided into multiple networks, and each with own range of addresses. Subnetting help in efficient use of resource allocation and also the utilization of IP addresses and better network management. So it helps to divide this type of single network, which is an IP address of uh, 200.1.2.1 to 4 different network with their own ranges. Then there is IP4 addresses to bits conversion. Basically, our devices, our PCs or the end devices understand only decimal or hexadecimal language. Means they understand only binary language, and we provide them data in a decimal or hexadecimal language. So if there is an IP address 192.168.1.1, 45, then the decimal value for this will be each octet, as the IPv4 has 4 octets and each of 8 bits. So the each octet will be represented in binary language with the which represents 8 bits. So every data here, like 192 is represented at 11.000.000. So this one is the binary value for 192, and similarly each octet will be represented in binary form, and which will come to the total of 32 bits. This is similar one. This one is the IP address of my laptop, and these are the binary values for each octet, and which this IP address is converted into a binary form, like 1100000000 1010 So this one is the IP address. So then there is another part, which is IP addresses is divided into two parts. Like first one is the subnet part, and second is the host part. So the firstly we talk about subnet part. It is also known as network part, and this part of IP address is basically the identifies the network to which the device belongs. So it specifies the network address and is used for uh, is used by routers to determine how to forward packet within the network. Then the size of this network part is determined by the subnet mask, and subnet mask is a 32-bit number. It consists of a series of consecutive zeros and ones, and followed by a series of consecutive zeros. The number of ones in the subnet mask indicates that the size of network. So these are the three networks, and like 192.168.35.17, and similarly there is another one 192.168.35.18. So the subnet part is basically the common part in the all IP addresses. So in these three addresses, the common part is the 192.168.35. So this one will be the subnet part, and the rest like 17, 18 and 19, these will be the host part. So host part is a part of IP address which identifies a specific device, and it distinguishes one device from another device within the same network. The size of host part is determined by the remaining bits. So these are the remaining bits like 17, 18 and 19. These are the last bits which are the remaining one except the subnet part. So this one is the host part. Then we move on to next slide. So the IP address is a location. So IP addresses are managed by regional internet registries (RIRs), which distribute different addresses blocks to ISP, internet service provider, and organization based on their requirements. Then there is dynamic and static IP addresses. So dynamic addresses are assigned to each device temporarily by by DHCP, and while the static IP addresses remain fixed, and this can be defined by the user, or but these remains fixed for a long period of time. So then it comes to the challenges with the IPv4 addressing scheme. So basically there is a main challenge to this is the exhaustion challenge, which means that there are limited number of IP addresses, like there are only 4 billion addresses in the IPv4 addressing scheme, and which leads to the exhaustion of the IP addresses. Like when if an IP address is if all IP addresses are used, and then after some time we have to repeat the same addresses to another device. So it's better way, and the solution to this problem is IPv6 addressing scheme. So as the IPv4 uses 32 bits, IPv6 uses 128 bits for addressing, and it is represented in hexadecimal format. And there is a main it focuses on the limitation of IPv4, that is limited address space, which leads to depletion of available addresses. Then it comes to IPv6, which offers large addresses with available of addresses for futures. Then the IPv4 32-bit address is divided into 5 classes: A, B, C, D, and E. Then, while the IPv6 employs 128-bit addresses a vast number of unique addresses with enhanced security efficiency as compared to IPv4. While also there are many type of IPv6 addresses like unicast, multicast, anycast, which enable different type of communication like one to one, one to many, one to nearest, and etc. So the IPv4, IPv6 basically offers us many features like security, large address space, simplified network configuration, and other support to different technologies like in IoT and other fields. While the IPv4 is a complex one and it has exhaustion problem and also the security vulnerabilities due to absence of security features. So these are the same like IPv4 limitation and IPv6 advantages. As the IPv6 supports mobile network, IoT, and also it has many features. So the IPv6 is the new solution and the new invention which leads to the uh, which satisfied the user needs and also the challenges with the IPv4 addressing scheme. And it is the future of IP addressing it as many devices are now using IPv6 addressing scheme, which like IoT, different IoT devices or 5G devices, and many emerging technologies use IPv6, and which led to the demand and the transition from IPv4 to IPv6 addressing scheme. So this was all about my demonstration. Uh, if you have any query, then please mail me at my email or text me at my phone number. Thank you.